I think you stumbled upon an interesting point, and it's like, yeah, these things are filled with sensitive technology, and as we all know, technology sometimes need to be serviced, right? So we're talking about preventing water from coming in, making sure that chemicals don't touch all these seals and stuff. But how do you accomplish this? How can you accomplish this while still being able to service the system?
Yeah, so I think it's a common misconception actually that like the act of housing all this and maybe locking stuff behind some doors makes it harder to service. I would say it actually, we typically see the opposite.
Welcome to Quality Lines, where we explore the innovations, challenges, and ideas shaping the future of quality control in food production. I'm your host, Winston Anderson. Today, we're driving into a challenge every food processor knows well: designing inspection systems that can stand up to harsh washdown environments. Our guest is Jon Gilchrist, an expert in engineering hygienic inspection systems for some of the toughest environments in food production. Jon, welcome to the Quality Lines.
Thanks, Winston. Happy to be here.
All right. Well, let's start with the basics. When I say harsh washdown, what am I talking about?
Yeah, so good question. I think what people generally refer to when they say harsh washdown is an environment specific to a lot of our customers and clients that we work with. You're going to find harsh washdown to mean, things like high pressure spray is being used to clean equipment. Often that spray might be elevated temperatures. You might have hot water washes. And really that harsh part comes in when we get to the chemicals. So oftentimes you will see detergent, sanitizers, and kind of heavy duty chemicals being used to make sure that equipment is left as clean as possible. In general, it's just a really challenging environment for equipment to survive in, really pushes it to the limit.
So it sounds like it's more than just making something like waterproof, yeah?
Yeah, 100%. So, I mean, at the end of the day, hygienic design, it's all about reducing risk. So, part of that is reducing the risk of damaging components, damaging the equipment. So, definitely, we want it to be waterproof. We want it to hold up to kind of that harsh spray. But there's also this focus, the hygienic aspect of it on reducing that biological, chemical, and physical hazards. So, whenever we talk about that biological hazard, right, we have to make sure that that equipment's easy to clean. There's nowhere for things to harbor away and kind of breed that risk. Chemical, we're talking about making sure that everything that is touching the food is able to touch the food without leaching, contaminants into it. We're not causing kind of, any kind of toxic elements to make contact with food that might go out the door, and as well limiting that physical risk. Making sure those materials aren't going to fall into the product. There's no hardware that's going to come off. So it's kind of this whole ecosystem of design choices.
Okay, cool. So if you had to talk me through a couple of the key design features for these systems, what would they be?
Yeah, so I think kind of where we often start is looking at things like component selection. So whenever we're building a system, we want to make sure that all the components that make that system up are also up to the task of surviving in this really harsh environment. So we're going to be looking at things that are, IP69 rated, oftentimes fully, stainless steel enclosures or kind of makeup. And then really, at the more important level is eliminating things like harborage points or those, physical hazards that I talked about. Uh, Anytime that we see components that maybe don't meet this, there can be a bit of a challenge. You might have to make use of things just based on what the market provides that don't meet these kind of strict criteria. So then you have to decide like how are you able to enclose it or otherwise kind of resolve that risk. I'd say the next element of our design, a lot of it is focused on good material selection. So whenever we're picking, for example, belts that might be in direct contact with the food, or even structural elements that kind of support the whole system, we have to make sure that we're using components suitable for that task. So, high grade stainless steels, certified plastics, things like that. There's a lot of kind of devil in the detail type design features that really round out the system. So, on the types of equipment that we build, you'll often see us rely on welding a lot to try to reduce hardware connections, really trying to avoid any kind of sealed faces that might be touching one another, avoiding just enclosed spaces. So you'll find our structures, we will design them with these open profiles with kind of an increased radius, a nice smooth surface finish on all points. Really just make sure that we can clean out and there's nothing that can hide from that sanitation team when they come through it. And then, of course, at the tail end of it, anything that is left that maybe isn't as accessible to a sanitation team, we need to look at how can we make that job more effective. So adding clean in place solutions, adding kind of access points to really get in and make sure there's nowhere for that debris to hide, right?
Okay. So we talked a lot about the outside of the system. I'm assuming there's things on the inside. Is that safe to assume, John?
That is safe to assume, yes. So,
Okay. So
inside,
how do
please
you
go ahead.
protect the stuff that's inside? I'm assuming it's full of sensitive tech.
100% correct. So, our systems more and more make use of really sensitive tech and advanced technology, right? A lot of the focus in designing something like a camera or a processing system, that manufacturer isn't really picturing the use case of putting this into an environment where someone's going to take a high temperature pressure washer to it. So really that falls to us manufacturers to make sure that we're adequately protecting it from any of the hazards that can occur on site. So, we have a couple of approaches to tackling that problem. One of them is, our favorite in a lot of ways is just removing that hazard entirely. So if we can relocate some of those key processing elements, things like computers or PLCs, even electrical panel items, if we can get those off of the production floor or at the minimum off of the actual product line itself and maybe over to a wall or a nearby location, that really helps us just minimize what we're trying to subject to that intense exposure.
Yeah.
For the things that we can't move away, that's where we rely on really heavy duty, robust enclosures, seals, custom, kind of access points to make sure that we are able to clean the parts that need clean, but maybe don't expose sensitive areas. And then, the third level to this is managing the risk that those enclosures themselves create. So anytime you put something into a box in these environments, you need to make sure you're controlling that temperature. You're not overheating the components, not kind of introducing more of a hazard by fixing it, right?
Sure.
So incorporating a lot of that temperature and environment control, resisting condensation, things like that is all highly important.
So I think you stumbled upon an interesting point, and it's like, yeah, these things are filled with sensitive technology, and as we all know, technology sometimes need to be serviced, right? So we're talking about preventing water from coming in, making sure that chemicals don't touch all these seals and stuff. But how do you accomplish this? How can you accomplish this while still being able to service the system?
Yeah, so I think it's a common misconception actually that like the act of housing all this and maybe locking stuff behind some doors makes it harder to service. I would say it actually, we typically see the opposite. It makes that job for people going to site or the site, players themselves. It makes their job a lot easier because what we are doing is we're naturally protecting the components that maybe require fine adjustment or fine control. So as anyone that's kind of worked on a car up here in Canada can testify, the hardest part is often when the bolt is totally seized because it's been exposed to the elements and it's rusted away. And, the act of changing a tire turns into replacing your whole front end, right?
Yeah.
We kind of avoid that scenario where, as soon as we have to go in and maybe it's refocus or replace a camera or a laser or something like that, everything is in this pristine, almost factory condition because of the way it's been protected.
Okay, okay. So is there anything you do to ensure that once the system hits the field, that it's going to survive?
Yeah, so we definitely, lean on some of our learnings over the years, right? Iterating on these designs. As you're aware, we have a long history, over a decade producing products for the food industry, starting in the baking world, now, more and more going into these harsher washdown environments. So really leaning on those iterative improvements we've made along the way is key. There are a couple of guidelines, outside of that that really help us steer in the right direction. So things like IP ratings on panels, manufacturer certificates regarding like chemical compliance and things like that are highly helpful.
Right.
But at the end of the day, the proof is kind of in the pudding, where you kind of design to the best of your ability, test it in house, with whatever we can to expose it in our production center, and then make sure that we're prepared to kind of iterate and resolve any issues that may occur.
Okay. So I'm going to go ahead and I'm going to go on a limb here and say that you've been in these environments before. Yeah.
Correct. Yes.
Yeah. Okay. Uh, as you're going around, what are some of the most common mistakes that you see?
Yeah, so I would say the biggest mistakes tend to revolve around not looking at like the big picture, or like the whole set of use cases on how someone's going to interact with that equipment. So, whenever I say this, it's very easy to hyper focus on that, production task that your equipment's been asked to do, that it might consume, 80%, 75% of its life cycle. But you also have to consider, like, how does that get installed? How does it get maintained, cleaned, and really come at it with that whole view. Failing to consider this is where we see, field modifications arising, and improvisations coming into place, where maybe things are being bolted onto the system. Maybe we're having
No.
kind of changes after the fact. And
Yeah.
oftentimes those aren't going to be done with the same sense of kind of care and critical attention to hygienic design as you would find in kind of the production office, right? So really making sure that you've mapped out how people want to interact with it, how we're going to keep it clean is key. Um, in terms of some specifics, where we see things go wrong, you might have, as an example, things like parts that need to be removed for sanitation that don't have a defined home or place to keep them during those sanitation processes. So, that key part that supports your belt
Yeah.
comes off for cleaning, and all of a sudden, whenever we go to start up, if that's not there, that's obviously a big issue. Some other, examples are just, how does it interface with other equipment? So what do those transfers look like? How does it bolt to the floor? How does, nearby access, and are we installing it too close to a wall or something where that inhibits the ability to clean it, right? So all of those kind of larger considerations are, I would say, are the most common issues that pop up.
I love that. So it reminds me of, like sometimes you go to fill up your car and you got the gas cap. There's a spot to put the gas cap on the inside of
Exactly.
yeah.
Yes. Yes.
And then you can't close it because it's connected, right? So
Yeah.
as long as everything works, stays
A
and it's just
hundred percent.
yeah.
Yes. Yeah.
Nice. Well, so far I've made a couple of assumptions, and I think that they are fairly safe. I'm going to ask you to make a go out on a limb and kind of guess where we're going to be in the next 5 years in this field. And I'll remind you, we are being recorded.
Oh, okay. Yeah. No, that's a good question. I would say in the next 5 years, just kind of expanding and extrapolating on the trend that we're seeing, right? Sites are paying more and more attention, like the both regulatory and just kind of corporate requirements to have this hygienic design as a key element of the equipment itself is really increasing. And that's putting a lot of pressure on manufacturers like us. But it also is creating a really great kind of well-supported market. So, critical components, things like, bearings, motors, actuators, belt materials, and even just materials, so like plastics and metals, things like that. We're seeing really improved access to those types of components meeting the strict requirements to really be a part of a hygienically designed system. Um, Increased traceability of all those components, plastics, etc., right? Knowing that that
Mhm.
wear strip that maybe got installed was actually made of this specific material, which can be traced back to a recorded lot number, at the manufacturer. So we can kind of show along that whole way that we're really preventing that chemical hazard that we talked about. The other, changes I think we'll see is again, kind of just extrapolating the trends, seeing people move from more traditional, like 2D top-down line layouts whenever they're talking about projects into these kind of 3D, almost twin factory type setups where you can get a better picture of all of those interfacing challenges, right? Highlight up front, hey, we're going to be too close to this wall, or how are these going to meet up? How do we make sure things are repeatably located while maintaining those hygienic needs? So I think being able to solve more and more of those problems in the 3D CAD and in the modeling before you have physically produced the system naturally kind of lends itself to an effective hygienic design process. Um, I would say the last element to touch on is, we're seeing obviously continued advances in things like the industrial Internet of Things and the ability to monitor and detect different conditions and environmental variables. So historically, the industry has taken a bit of a reactive approach where you're kind of relying on waiting for something to go wrong and then solving that. Increasingly, we're seeing sensors being used that might pick up increased humidity in those enclosures that I talked about, excess vibrations in motors, drive shafts, etc. And that can help us alert to potential issues before they actually occur and create more of a hygienic issue, right? Being able to change the gearbox before it starts leaking oil, being able to uh, get in and dry out and seal up enclosures before components are being damaged. That proactive approach, I think, is really going to take hold in the next couple of years.
Oh man, okay. I have a feeling you got it. I think we'll be able to revisit this in 5 years, and I
Yeah,
think you'll be all right.
perfect.
Well, it, so if I kind of put myself in the shoes of somebody who's responsible for provisioning this type of equipment, like as I'm listening to all of these things that you're saying, I I'm fairly frugal, and I can kind of see the dollar signs going up in my head. Like, hey, yeah, that sounds great, but So if you were in my shoes, what would you say to kind of help me ease my mind?
Yeah. I'll start off by saying you're not wrong, right? All of these things can come with a cost. Upfront equipment cost is definitely one of the challenges we face in kind of managing the adoption of hygienically designed systems. The typical way we want to have that conversation and what we try to show our customers and people purchasing similar equipment is really the long-term benefits this can bring to you, right? Like a great example is thinking about the amount of time that goes into cleaning a piece of equipment over its entire lifespan, right? So you can look at that and say, hey, I can pay $0 and I can cut off that clean in place option today and save a bit of money. But then every single night, I'm going to pay someone to spend their time on that equipment, cleaning it up and
Yeah.
keeping it going, maybe disassembling, reassembling. So all of a sudden, that upfront cost is really quickly outpaced by that kind of long-term, repetitive expense of inefficient operation effectively, right?
And I
So
suppose that comes with
adding,
additional risk as well, right?
Yeah,
Yeah.
100%, right? That's where, parts might get lost, broken, that disassembly we're talking about, right?
Uh-huh.
So definitely, not spending the time and money up front can be a huge impact on your overall kind of lifetime cost of that equipment. So,
Not to mention the
um,
downtime.
100%, yes.
Mm.
So, when we look at maintenance, sanitation, any manufacturer who's really pushing hygienic design, they're considering all of these factors, right? Again, talking about kind of that whole picture instead of just the, in production use case. If we can shave 15 minutes off of a routine maintenance task, or 30 minutes off of a routine sanitation activity over the lifespan of that equipment, you're talking huge savings. And even with the current labor markets, right? Like sometimes it's even a trouble to find people to do it. So
Cool.
it really just helps us all around.
Okay, well, tell you what. Let's say you won me over. What's another piece of advice you could give me?
Um, I mean, I think the biggest piece of advice I'd give is work with the experts and with the resources that are available to you, right? Like the great thing in today's world is you don't need to be an expert. The information is fairly accessible to kind of connect with people who can really help guide you to making good hygienic design decisions. Whether that's your equipment supplier, whether it's kind of third parties, there are resources out there, and I would really recommend people seek those out and have those conversations to really save themselves time and get up to speed and have the most hygienic option they can.
Okay, awesome. Well, thank you very much. We're gonna shift gears a little bit here. We're gonna go into what's called the rapid fire round, and you can kind of
Love
picture
it.
this as if you're like it's not going to be happening now, but maybe there's like some fast-paced music happening in the background.
Ooh,
I mean,
okay.
like we're looking for some quick, short answers to these
Yeah,
questions. All right, I got five
I'll,
questions.
I'll move in.
That's right. All
Get
right,
ready.
all right. Is your hand on the buzzer?
It is. Yeah.
Okay. What's the most common equipment weak spot in washdown environments?
I would definitely say that field modifications that I touched on,
Oh
right? Like
yeah, okay.
someone bolting something up to it afterwards.
Okay. What's the biggest misconception you hear about washdown systems?
I would say IP rating being the most important thing is the biggest misconception.
Ah, okay. All right. What's the next big breakthrough you'd like to see in hygienic design?
I would say it would be really cool to see, some significant material advances. So, antimicrobial materials, things like self-healing, self-cleaning surfaces, stuff like that would be quite cool.
That's some pretty cool. Okay.
Yeah.
Now, if you had to pick one song to play while you're on site doing an installation, what would it be?
Ooh, that's a good one. If I had to pick one song, I think I'd go back to my days of university studying, putting on like a 10-hour lo-fi uh, song on YouTube and just let it ride. Yeah,
Wow. Okay. Nice. Very
yeah,
zen.
yeah,
I'm at the opposite end of that spectrum.
yeah.
And then yeah. Either way, uh, what's your go-to tool in your toolbox?
In terms of hygienic design, I would say it's the team that I work with is my go-to tool, right? I
Ah,
don't think I try to do everything myself. I think we have a really deep and knowledgeable team, and that's key in being able to solve these problems.
okay, nice. Now, assuming that they aren't listening, what
Yeah.
what's the actual tool?
uh, I'm not sure. Yeah, yeah, yeah.
All right, good. Well, I think you survived, John.
Perfect. Yeah, yeah.
Well, good. Well, I appreciate you spending some time with us here today, and appreciate your expertise.
Yeah, no problem. It was super fun. Hopefully we'll get a chance to do it again.
I think we will. For our listeners, if you want to learn more about vision inspection systems for meat and poultry plants, you can check out the episode notes for resources and links. If you liked what you heard, please like and follow the Quality Lines podcast. Once again, I'm Winston Anderson, and whether you're inspecting, testing, or just digesting, thank you for joining me on the Quality Lines. Very much.